Today we're doing section 6.5 and we're going to be focusing on complex numbers in polar form. So complex numbers would be an imaginary number, so when we have this whole a plus bi value. So when we are in polar form of a complex number, one thing we need to discuss is that our axis is slightly different, just like polar was a little different. So a complex number looks like this, where A is your real part and B is your imaginary part. So when you're graphing a line, A represents your x-axis and B is your imaginary axis. So just like we had a slightly different way to plot polar coordinates, there's a different way to plot complex values. So to kind of take all these formulas that we've known already, we have to kind of transfer them and get rid of the x and y and introduce this a and b. So the one formula we know is a squared plus x squared plus y squared equals r squared. So that's going to be phased out, and we're going to be writing a squared plus b squared equals r squared. Similarly, we know y is r sine of theta, so instead we can say b is r sine of theta, which means a is r cosine of theta. And lastly, tangent of tangent of theta. Tangent is always y over x, so in this terms it's b over a. These are four important formulas. Again, the other four we've used so much that they're kind of memorized by this point. These you might want to jot down so that you understand the polar form of these. So next I want to discuss how to write a polar coordinate or polar equation in complex number interpolar. So they use this letter z to represent our polar coordinates, or our complex coordinates, sorry. And we're going to use those formulas that they just gave us. So they said that a is equal to r sine of theta, and b is equal to r cosine of theta, and then this has the imaginary unit I. And notice that they both have an r in common, so I can pull the r out front and say that it's sine of theta plus actually I'm looking at this and I made a mistake up here. A was r cosine of theta and b is r sine of theta. So that's going to change this. So when I factor the r out, I'll be left with cosine of theta plus I sine of theta. So this is the complex number written in polar form. So again, you might want to jot this down. So this is our complex number in polar form. We're going to do some practice on plotting and converting our coordinates today. So for our first example, our polar, or our complex number is z equals -2 minus 2i. And the directions are to plot and then to convert in polar form. So write in polar form. So to plot a coordinate like this, we draw our xy axis, but instead of x and y, we think about it as a and b. So here's my a, and b represents our imaginary. So this is a, and this is our b. So my real is -2, so I go left 2, and my imaginary is also -2, so I go down 2. And where they intersect would represent that coordinate right there. So now we have to put it into polar form, but in order to do that, I need an r and a theta. So to find that, I can use a squared plus b squared equals r squared. So I'll have negative 2 squared plus a negative 2 squared equals r squared. So 4 plus 4. So we get 8. And we take the square root of 8. I know 8 breaks down to be 4 and 2, so 2 root 2 is our r. So that's half the battle. Now I need to find my theta. And tangent of alpha, or tangent of theta, is equal to b over a. So tangent of theta is equal to negative 2 over negative 2, which equals 1. So now I have to figure out what coordinate we're talking about. So I know the only time I get 1 for tangent is when my angle is a pi over 4, but I can clearly see that we're in the third quadrant, so I need to take this and I need to find the third quadrant equivalence. So my theta is actually 5 pi over 4. So the last thing that we need to do is take the r, take the theta, and instead of setting it up as a coordinate, I have to kind of represent it as like that polar form of the complex number. And let me switch the screen to write that final answer. So the polar form is z equals r cosine of theta plus I sine of theta. So I just fill in the values. So I have 2 root 2, and then it's cosine of a pi over 4, 5 pi over 4, plus I sine of 5 pi over 4. And that is our final answer. If they asked you to go into rectangular, that's when we would go one step farther and use the coordinates. So our next example is going to be just that. So the next example is write z equals 2 cosine of pi over 3 plus I sine of pi over 3 in rectangular form. So notice it's already in polar form. So here's the complex version in polar form, and then I want you to put it in rectangular form. So this is where we use the actual coordinates to replace this and get actual values. So I know that my coordinate for pi over 3 is 1/2 root 3 over 2. So I'm going to go down to this equation, z equals 2. Cosine of pi over 3 is the x part of the coordinate, so that becomes 1/2. Plus I. Sine of pi over 3 becomes root 3 over 2. Inside the parentheses, I have common denominators, so I can write this as 1 plus I root 3 all over 2. And notice out here, this is a 2, and that means it's technically a 2 over 1. So these 2's are going to cancel, and the rectangular form of this coordinate is 1 plus I root 3. And that's our final answer in rectangular form. So that's it for today. We'll pick up with this tomorrow.